Evaluate the infinite series by identifying it as the value of a derivative of a geometric series. Okay, let's do the sum of n over 4 to the n. The answer is 4/9. How'd they come up with that? I mean, this hint is very important. Write it as 1/4 times f prime 1/4, where f is this. That's the geometric series we want to use. First off, why? I'll do that and we'll get an answer. But why is it right? Because if we take this geometric series right here, we say, okay, f is that series, sum from n equals 0 to infinity. This is f of x of x to the n. And if we take the derivative, let's change the color for clarity. We take the derivative, of it. What do we get? Well, it goes to 1. Whenever you do the derivative, you lose the first term, right? You go from 0 to 1 because the first constant, right? If you plug in 0 here, this equals, let's be clear here, this is x to the 0 plus x to the 1 plus x to the 2, da, da, da. And x to the 0 is just 1. And so when you take the derivative, that goes away. And we're starting at 1 now. That's why you do that. So this becomes what? Bring down the n x to the n minus 1. That's the derivative, right? So now if we take that derivative and do what they're saying here, f prime of 1/4, we plug a 1/4 into that. What do we get? We get the sum from n equals 1 to infinity of n times 1/4 to the n minus 1. Okay, so that's close. You think, is that the same as this formula? Almost. Almost. Now, bring it on down, let me show you. If we now, right, put the sum there. Sum from n equals 1 to infinity, and 1/4 to n minus 1. If we multiply both sides of this by 1/4, like they said, by 1/4, then 1/4 f prime of 1/4 will equal what? Well, this is sum equals 1 to infinity, n times 1/4 to the n minus 1 times 1/4, okay? And so what is that gonna do there? That's going to add powers, right? N equals 1 to infinity of n times, this is to the first power, right? Whenever you have same bases multiplied, you can add powers. So that'll make it 1/4 to the n minus 1 plus 1. And those will cancel. It's just 1/4 to the n. And so is that the same as that formula? Yeah, it is. Because that's now the sum n equals 1 to infinity of n over 4 to the n. That's the same thing as 1/4 to the n, 4 to the n on the bottom. That's the same as the formula they have there. So that's why 1/4 f prime of 1/4 does equal our original formula. So that's all just showing it's the case. So therefore, that'll work. If we take 1/4 times f prime of 1/4, we can find 1/4 times f prime 1/4. It will equal our original formula. So you don't really need to do that. I'm just verifying that this will do it. So how do we do that? Well, you go, okay, so the f of x is the sum from n equals 0. I'm just going to write sum. I'm tired of doing all that. Sum of x to the n, which is what? Well, according to the geometry, you go to the notes here. Here's the notes. The sum of x to the n is 1 over 1 minus x. So you just want to use this. This is the basic geometric series, power series, geometric series formula. So it's right there. Sum of x to the n is 1 over 1 minus x. So that's equal to 1 over 1 minus x. So f of x is 1 over 1 minus x. And we already proved that if we can find 1/4 times f prime, we'll get our answer. So let's take f prime. How do we do f prime? Well, let's rewrite this. This is 1 minus x to the minus 1. So the derivative, bring down the minus 1, 1 minus x to the minus 2, subtract 1 from the power, times, drew to the inside, chain rule, don't forget about chain rule, drew to the inside, -1, right? Because there's -1 in front of that x. And so this negative and that negative cancel, and we have f prime of x is positive 1, 1 minus x to the minus 2. Okay, but we've already proven that what we need is 1/4 times f prime of 1/4. So so let's first well, let's just do the whole thing. 1/4 times f prime of 1/4 is what? We'll multiply 1/4 on the front first time, and then plug in 1/4. Okay, so what's that? That is 1/4 times 3/4 to the minus 2, right? One whole candy bar, take away a fourth of a candy bar, leaves you 3/4 of a candy bar. And so that's equal to 1/4. And that's going to be 3 to the minus 2 over 4 to the minus 2. You can flip those, right? 4 to the plus 2 goes up, 3 to the plus 2 goes down. And so that's 1/4 times 4 over 3 times 3, cancel, cancel. 4 over 9. Boom, we got the right answer. That's the answer that they had up here. So do you see what we did? We really didn't need to do all this. We could have just followed their hint. We could have just said, look, I'm just going to find out. They're telling me 1/4 times f prime of 1/4 will be my thing. And so I did f prime. And we had to go back to the geometric series form. You have to know what the sum of x to the n equals. That's really important. That's in the notes. 1 over 1 minus x. So I said, okay, this f, which is the sum, is 1 over 1 minus x. Right? I said the f is the sum, and that sum of x to the n is 1 over 1 minus x. So I took the derivative, and then I multiplied 1/4 in the front and plugged in 1/4. Simplified it, it's 4/9. But why is that right? Well, I proved over here that if you do take the derivative, right, you bring down the n and you multiply 1/4 on the front, that will indeed equal the question they asked us. So we know this answer is right. And so there we go.